Okay, here we've got a question covering several different numerical methods, starting in the first one with Simpson's rule. Now, if it's part A that's causing you the difficulty, you need to go back to your notes and look at a worked example, and I've done a video worked example of Simpson's rule. It's always the same process, so I'm assuming that it's part B that you're really interested in for this video. So in part B, we've got a curve intersecting a line, and the point where that happens is when x is alpha, and we've got alpha between 0.5 and 1.5. It's a show that question, so we're going to end up by saying there's a root alpha between 0.5 and 1.5. And of course, for a root in a particular interval, it's the change of sign method. So you need an f of x that has got to equal 0. Where's that going to come from? Well, you've got two graphs intersecting. So when the two graphs intersect, it's a very easy case of simultaneous equations. So this graph has got to agree with that one, and then you need to rearrange that equation so you've got 0 on one side. You do f of 0.5, f of 1.5. You should get a change of sign, and you make the standard statement after that, which you've got in your notes, important to state clearly, ending with the fact that alpha is between 0.5 and 1.5. Then we've got another show that question. So we've got this equation. Oh, that may just be the equation you had to deal with up there. This equation has to be turned into that one. So here's your starting point, here's your end point. You need to work forwards from that until you get this. But of course you can combine that with working backwards. If you put 3 to the power x equals x plus 3 at the top of the page, and you put x equals log of x plus 3 over log 3 at the bottom of the page, it's just as legitimate to work back up the page as it is to work down the page. And I suggest you do that in this case, because the obvious thing to do is to rearrange this so you've just got plain old log of x plus 3 on this side. So you've done something with the log 3, so you get what you've got on this side. And then think, if we've got x plus 3 and we've got this, what working forwards now we probably have done to both sides in order to get this. So what have we put in front of log of x plus 3? We must be doing the same thing to 3 to the power x, and then you've just got to explain, probably just to yourself, why these two things agree, because there's a rule of logs being used. Then in part 4, we've got the cobweb or staircase diagram. I haven't got figure 1 handy, but what you need to do is start from the position of x1. So you need to find 0.5 on your x-axis. These always have x and y axes, and the line y equals x is always drawn on the handout. You need to find on the x-axis the point 0.5, and then you go vertically, but not to the line, you go vertically to the curve, wherever the curve may go, follow it horizontally to the line, and wherever that is, make sure that you put new blobs on the x-axis and label them x2 and x3. This one can be labelled x1 at the beginning. And also put arrows to show exactly the direction of the lines as well, I would recommend.